So let's just run over some practice of describing distributions. Remember, the things you're looking for are the shape, whether it's symmetrical, positively skewed, or negatively skewed. Also, are there any outliers that you can talk about? How spread out is the data? And where is the center if you're comparing one distribution to another? So let's run through a few examples. Here we have 6 different histograms. Now say you were asked to describe these. Hit pause on your computer there and have a look at them, have a go, see what you think, and then I'll run through the answers. Okay, so this first one here, what's the first thing you notice about it? Well, I would say that it's got an outlier here. So in describing it, I would say there is one outlier up in the positive number region. Now let's talk about the shape, because I can see that this has got a skew. It's got a mountain and it's tapering away in one direction. Now is it tapering away in the direction of positive numbers or negative numbers? Put your pen on the top, roll down the hill. Which way is your arrow pointing? It's pointing towards positive numbers. So this is positively skewed with an outlier. Now, because we're not comparing it to another, we're probably not going to talk about the center, like is this center different to another one? But in terms of the spread, it's also, spread is really when you're talking about one compared to another, but this one I would say is quite bunched up. You know, this is all quite close together. What about this one over here? Again, you can see there's a skewing to it. If we put our pen on the top of the mountain and we roll down the mountain, our arrow is pointing in the direction of positive numbers. So this one again is positively skewed. There are no outliers that we can see. The center is roughly in the same spot as was over here. The center is kind of in the same spot, but you can see that it's much more spread out. So if these two were drawn on the same scale, I would be saying, well, this one has quite a small range, it's not very spread out, and this one has quite a large range. It's quite widely spread out. What about this one here? Does it skew in either direction, to the left or the right? Not really. It's roughly balanced on either side. There isn't a really clear pattern to it. So, you know, if we went down either direction, it's roughly the same. So this one is going to be symmetrical. And are there any outliers that you can see? No. We could also talk about the center. So we'd read off what this number is and talk about how that's roughly where the middle of the data is, and how spread out is it. If these are all on the same scale, this one is very widely spread out, so it has a large range. Okay, what about this one down here? Bottom left. I can see a bit of skewing to this one, so I'm going to put my pen on the top of the mountain and roll down the mountain, and which way is my arrow pointing? Towards negative numbers. So we've got a negatively skewed histogram here with no outliers. And this one's quite spread out, so it's got quite a high range. What about this one here? Well, we've got a little friendly outlier in the corner there, so we're going to comment on that and say this one's got an outlier. The rest of the distribution, though, is fairly symmetrical. It doesn't really have a skew to it. It's mostly balanced. So I would say symmetrical with an outlier. And in terms of the center, we'd read off, you know, what this is down here and talk about the center, say compared to this one over here. The centers are very similar, but the ranges are quite different. So how spread out they are, if you're comparing these two, that's something you could comment on. What about this one over here? This is a bit of a stumper. This has got 2 peaks. So this isn't the standard kind of thing that you would talk about. You'd want to mention this in other ways, but it's just a common sense approach. You could say there are 2 peaks to this, and one is positively skewed, one is negatively skewed. There's 2 rough groupings of how these results have come out. So even though this is one data set, you might find that, say you say it's age of year 12 class or something, and we're measuring it by, you know, down to the day. It's not just 16-year-olds, 17-year-olds, 18-year-olds. Say we had a lot of people who are roughly all 16 and a lot of people who are roughly all 18, but no one in the middle who is around about 17, which could come about maybe because of the cutoff dates when you go into prep, or, you know, I don't know, something like that. So you would make, depending on what the data is, you would look at it logically and say, well, what could be a cause that creates these 2 peaks? And then you would just talk about it in that way. Okay, now here we have some box plots. and have a go, hit pause, see if you can describe these, and then again I'll run through the answers in a minute. Okay, so let's start with this one in the top left-hand corner. What does the shape of this one look like? Well, where's the center of it? Center's round about here, and does it taper off in either direction? There'd be a short tail there. This is the top of the mountain, remember? It looks like it's rolling down the hill that way because this is the longest line I can draw. That's a short line that way, and they're definitely not the same length. You know, this one is short, this one is long. So here is a skew in this direction. It's going in the direction of positive numbers, so this one's positively skewed. And doesn't have any outliers, so we wouldn't need to comment on that. If we're talking about the center, you might want to say, you know, this is roughly where the, whatever number this happens to be on the scale, this is roughly where the data is centered around, and do some comparison to, for example, this next one, which is centered around about the same place, but the distribution has a very different shape. So what about this one? Does it have a skew? Well, this here is going to be the point of the hill, and we could go a short distance out to that one, or we could go a longer distance out to this one. So it's actually skewing in this direction, which means it's negatively skewed. And what about this little fella over here? It's got an outlier as well. Now, in terms of the center of the data is roughly the same as with this distribution. So they have similar center of data, but the rest of the data doesn't follow that pattern. This one has a tendency towards higher numbers after that center, and this one has a tendency towards lower numbers after that center, except for this freaky little guy out here, of course. And in terms of the spread, this one's very bunched up. It's all close together on the scale. So this one has a small range and a small IQR, because from a box plot you can read the IQR off really easily as well. That might be something you mention. And compared to this one, this is really spread out. It's really far along the number line. So this one has a high range and a higher IQR. What about this one? This one right here. How would we comment on this one? To me, this looks roughly symmetrical. From the middle going out either way, either side, it's pretty much balanced. So I would call this symmetrical. And there's no outliers that I can see. The center of the data falls roughly about here, so we might make some comment on that if it in comparison to something else, or you know, if that's a figure that's worth talking about for some reason, depending on, you know, what it is that you're measuring. And the spread compared to this one up here, for example, it's quite spread out. So you know, you could comment on the range or the IQR. What about this one? Definite skewing going on. Here's the top of the mountain, and it's going out that way, so it's negatively skewed. And we've also got this character here who is our friendly neighborhood outlier. So you would make some comment about him and why he's got such a different pattern to him than the rest of the data, because you've got a lot of stuff happening down the bottom. You know, the histogram looks like this. It's really spread out, and then you've got, we've got a peak coming up over here, and it's coming down a little bit again, and then there's, one guy right out there. So how come there's a lot of people spread out amongst the bottom here, but there's one guy really, really tall? Or, you know, fast, or whatever you happen to be measuring. Okay, what about this one? This, I would say, is fairly symmetrical, because again, even though it looks like this one, it's just smushed up more. It's roughly balanced going out either side. So we've got some symmetry here. Symmetrical. Oh, I didn't write that up here, by the way. That one's symmetrical too. So this is symmetrical, but it has a much smaller range than this one here. It's far less spread out, so the spread is quite small. So you could talk about the IQR, which is the distance from there to there. It would be quite significantly different between this one and between this one here. You could talk about the range, which is taking the highest number, minusing the lowest number, and talking about that distance from end to end. The other thing that we would talk about here is these guys, outliers. There's a couple of them. So you would say there's 2 outliers at, you know, and then say what the points are. And finally, this one over here, what would we say about this? Well, again, I see a serious skewing, so I'm going to put my pen on the top of the mountain and see which way it goes. That's the longest arrow I can draw, because this one would be really short, so that's not going to do me any good. So we're pointing towards positive numbers, so it's positively skewed. And we have another outlier. So you would say, and this one has an outlier at blah blah blah, which is, interesting because of XYZ. And the interesting part is based on, what it is that you're measuring. So it's just common sense stuff. If you're talking about heights, say something about, why was this person so short? Is this person a lot younger than everyone else in the group, for example? Or, if it's speed that someone's traveling down the road, some people are going roughly in the speed limit or something, and some people are speeding. And then here we've got grandma down here who decides she's going to drive down the street at 20 kilometers an hour, what have you. So you would make a comment logically based on what the data is.